Hello, in this video we are going to preview the College Algebra Quiz 8 really quickly. This is another nice quiz because it has 6 questions, so that gives you an extra opportunity to get another question right, which should be helpful. For number 1, we're dealing with a piecewise function, and in this problem you are given the function and you have to first draw it and then evaluate it and find the range. So when you're drawing these functions, there are two things to watch out for. First one is make sure you get your function right. So you're going to be looking at the piece on the left written here. These represent 3 different functions that you'll need to draw on your graph. But then the second thing to watch out for is to make sure that you get the right domain for each piece. For part B, the question is simply asking you to plug an x value in to get a y value. And you can do that in 2 different ways. You can either plug it into the function itself up above, which would require you figuring out whether your x falls into this category, this category, this category. Once you know which category it falls into, then you can decide which of the 3 functions you need to use to find y. Or, probably the easier way to do part B is to actually just look at the graph that you drew and find the y value for each x value. For part C, you're going to be identifying the range. Of course, the range is our y values, and they want you to put your answer in interval notation. So that's going to look like this. You might have some brackets, or you might have some parentheses. You might have some unions in between. You could have, 1 bracket, 1 parenthesis, something like that. But that's interval notation, and that's how you want to present your answer. For part 2, we've got another piecewise function, but this time they gave us a picture, and they want us to write the function. So A is very similar to the last problem where they're giving you an x value, they want you to find the y value. The easiest way to do this is going to just be to look at the picture. So you'd find your x value, say -5, 1, 2, 3, 4, 5, and then your y value at that point, plug it in, or write it there on the line. For part B is actually probably a little bit tricky. You're going to first have to figure out what each of your 3 functions looks like. So here's our first function, would go on the red line. Your second function, the one in the middle, would go here on the green line. And your third function, this blue one on the right, would go on the blue line here. So when I say function, what I mean is you're going to have to come up with a function or a formula that represents each one of these shapes. So that's going to require you to remember parent functions and then transformations. So if you're dealing with a line, has it been shifted? Has it been shifted up or left, etc.? If you're dealing with a parabola, has it been shifted? Has it been flipped? Has it been stretched? And that will help you come up with the formula for that function. But also keep in mind that each one of these functions has its own domain. So you'll have to look at the domain of each one of these. And as you're doing that, one thing to watch out for is, I'm going to erase some of these color marks that I made. One thing to watch out for when you're looking at domain is whether you're dealing with open or closed circles, because that's going to make the difference between x is less than -3 or x is less than or equal to -3. So little details like that are going to make, be the difference between a wrong or a right answer. All right, I actually almost missed part C down here. They want you to identify, again, the range, and this time in interval notation as well. So we're looking at brackets, maybe parentheses, maybe some unions, things like this in your interval notation. Question 3 is just a straight transformation question. So they start you off with h of x, and we don't really care what h of x is. All we care about is that it is a parent function. That's our parent function. And truth be told, we don't need this picture. This picture is completely irrelevant. It doesn't even matter to us what h of x looks like. All we care about is what's written right here. They've taken h and they've transformed it in Q. And the way they've transformed it is with a negative, a 3, this -2, and this -2. These 4 numbers and their locations are going to create 4 different types of transformations, and you have to list them. So a couple words of caution. First of all, in class, a lot of times I use kind of casual language. I say things like, oh, the negative sign is going to flip the function upside down. But that's not formal math language. I do that really just for sake of conversation. But you need to use formal mathematical descriptions here. So instead of saying flip it upside down, you might say reflect across the x-axis, for instance, or reflect over the x-axis. That would be the mathematical way of saying it. So you're going to need to determine what these 4 pieces do, flip, and then where. Where does it flip? How does it flip? Maybe a stretch or a condensing, maybe a shift horizontally, a shift vertically, which direction, those sorts of things. So list all 4 of those. And again, you can ignore the picture. You don't even need the picture there. Okay, question number 4. We have our parent function in blue and our transformed function in red. Well, it's like a purplish color. This one, you have to come up with the transformations that can describe what changed between the 2 functions. So I am actually going to give you a little hint on this one, and I'm giving you more information than I probably should, but it's because I want you to be prepared for this very tricky problem. Notice that going from F to G, we actually have 2 flips. We have a flip over the x-axis, which turns it upside down, and we have a flip over the y-axis, which kind of flipped it from right to left. So we have 2 flips. That, if I were to just write out my parent function here. So here's my parent function. The flip over the x-axis is represented by a negative out front. A flip over the y-axis is represented by a negative inside the parent function. But here's the trick. Whenever this happens, it creates a set of parentheses inside the parent function that is necessary. So you might even also have like another number here. It might be like plus or it might be a minus. But notice that this negative sign is going to have to distribute through the parentheses here. So the flip, where this flipped across the y-axis, is going to create a negative sign inside the parent function, which in turn creates a set of parentheses inside the parent function, which in turn is going to change this sign. So a lot of steps here to keep straight, and I just wanted to caution you about what was going to happen in this problem, because I have a feeling it's one that a lot of students are maybe going to forget a couple of these little steps that are very important, and they'll change your answer. Okay, for part 5, this is a pretty straightforward problem. They want you to take -3 and plug it into G. Well, to do that, you're going to have to know what G is, and then inside of G, there's an F, so you're going to have to know what F is, and they give you all the information you need to know about F in order to figure this out. I don't want to give you too much more information because I think this one's pretty straightforward. So let's move on to the last one. Question 6 is a word problem about constants of variation. Now, be careful because this problem involves 2 types of variation. There is a direct variation and an inverse variation. And if you don't remember exactly what those do, I recommend that you go back to the constants of variation video, because there is an example problem in that video that is identical to this one in almost every way. It's even about resistance and wires and things like that. So, a couple of notes. For part A, you're going to be plugging numbers in for R, D, and, well, I said it backwards, but L, D, and R. You're going to be plugging numbers in for your various variables in order to find a number for K. So your answer for K should be some value that you can calculate. However, for your variation equation, your goal here is to write an actual formula, an equation that has variables in it. So your equation will definitely have an equal sign because it's an equation, but it will also have an R, an L, and a D in it. You won't be using these values in your equation. You will go back to the variables in the equation. You will, however, have a number in there somewhere which comes from here, the K. All right, finally, once you've done part A, part B should be really easy. You're going to use this variation equation. You're going to plug these values in for your variables, and then you're going to solve for what it's asking for you to solve for. Okay, that's a wrap. Good luck on your quiz. If you would like to receive feedback on this quiz, I'm going to be providing that feedback on Wednesday. So you'll want to get this done before I provide feedback on Wednesday. So I would recommend trying to get it in Tuesday night. If you get it into me early Wednesday morning, that's probably fine. But I don't have an exact time for you Wednesday, so I'd recommend getting it in Tuesday night so that you don't brush up too close to when I provide feedback. All right, good luck.